Hey guys, sorry about that. Little tech issues. So, as I was saying, since p is negative 10 and the negative axis is down, this is going to open down. Okay, so we know our vertex, we know our focus, we have our directrix, and our graph opens down. Okay, let's look at example 3. So now we have something that we can see is clearly shifted. And so we need to be able to identify our p-values, our h and our k value. Now, a very important thing here is to remember the formula for these situations. So come back up here and look. So this one had a y value being squared. Okay, so we were dealing with a horizontal axis again. And notice our equation, it's y minus k and it's x minus h. So if we come back to this example, to get this equation into the same form, we need to change these from y plus 4 to a y minus, in this case it needs to be negative 4, equals 12x minus, so instead of plus 3, it's minus negative 3. And so we have to do that because to get these to fit into the form that we need it to be the form of y minus something and x minus something. And since it was y plus 4, the equivalent version of plus 4 using subtraction is subtract negative 4. Okay? If this equation was y minus 4 squared, we would not need to do this. We know our k would be 4. Okay? But since it was y plus 4, we have to do this little kind of switch. And so what we get is that h is equal to negative 3, k is equal to negative 4. Now, again, this 12 is our 4p. So I know that 4p equals 12 divided by 4. And p equals 3. All right. So we have our h, we have our k, and we have our p value. This gives us everything we need to be able to find our vertex, focus, and directrix. Okay. And very simply, our vertex is going to be h comma k. So it's going to be the point negative 3, negative 4. Our focus, okay, since this is a y squared, this is a horizontal opening graph, our focus is going to be 0, comma, k plus p. So since our k is not 0, k plus p. Our focus is going to be h plus p, comma, k. Oh, that didn't sound right. So our focus is going to be h plus p, comma, k. So since h is negative 3 and p is 3, h plus p is 0, and k is negative 4. Now our directrix is going to be the line x equals h minus p. So we get negative 3 minus 3 gives us negative 6. Okay. So we have this nice form here where we have our vertex is negative 3, negative 4. Our focus is 0, negative 4, and our directrix is x equals negative 6. So let's sketch a graph of this. So since my vertex, let's go negative 1, negative 2, negative 3, negative 4, negative 8, -4, -6, -3. So since our vertex is at -3, -4, puts us right there. So that's our vertex. Our focus is at 0, -4, so that puts our focus right here, about here. And our directrix is x equals -6, which would be right here. Okay. Now our p-value is 3. Okay. So since we know we're opening horizontally and p is positive, we're going to be opening to the right. So I know this graph is going to roughly go like this. Again, always mind my terrible drawings. Now, how in the world could I graph this on my calculator, right? We know we could graph any like the x squared, right? We just solve for y and it's not too crazy. But what we do to graph this on our calculator is actually really simple. We just have to graph kind of the upper portion and lower portion as two separate functions. And so we take our y plus 4 squared equals 12x plus 3. And the first thing I'm going to do is I'm going to square root both sides. So I get y plus 4 equals plus or minus the square root of 12 times x plus 3. And then we just subtract 4. So we get y equals -4 plus or minus the square root of 12 times x plus 3. So what that does is, kind of going more into calculator lingo now here, y1, so our first y equation, could be -4 plus the square root of 12 times x plus 3. And then our y2, our second equation, would be -4 minus the square root of 12 times x plus 3. And so then if we use our calculator, we can plot these two functions here, giving us kind of our upper and lower halves of this horizontal parabola. And there you have it. Now, up here, this was a pretty simple one to get into a thing that we could graph on our calculator just by simply dividing by -40. But when we're shifting, we're going to end up with, this y plus 3s and things like that. And it might be a little more complicated or just a little more messy, if you will. But ultimately, you can just kind of slow yourself down, piece it out, and you can get it graphed pretty easily. Okay, so example 4. Okay, we're almost done. We've got a couple left after this. So we want to find the equation of the parabola with the focus of -6, 3 and the directrix y equals 1. Then give a rough sketch of the graph. So using the focus and the directrix, very easily, y equals 1 being the directrix tells us that this is going to be a vertical axis graph. So what we know is if you start graphing this, our directrix is y equals 1. So that's going to be up here. And our focus is -6, 3. Okay? That's -6, 3. So what's really cool is if you remember, we talked about this all the way back at the beginning. Let me jump all the way back up here to the beginning. Right? This green here, right? We talked about the distance from these 2 points. Right? That distance is p. So halfway between the focus and the directrix is always going to be our vertex. So since I know this is y equals 1, and this is the point -6, 3, halfway between there is going to be our vertex. And our vertex in this problem is going to be at -6. Now, y equals 1 and -6, 3. So halfway between those would be -6, 2. Okay, so that's really cool. So that gives us our h and our k. So our h is -6 and our k is 2. But what's even cooler than that is this also tells us our p-value, because remember, our p-value is the distance from our focus to any other point on the graph. That's our p-value. Or sorry, the focus to the vertex. The distance from our focus to our vertex is 1, so this tells me that p equals 1. Bam. Now let me erase this. So since p equals 1, it's positive. We know our graph is going to open like this. So there's our sketch. We've got our sketch without getting our graph. That's pretty easy, right? Once we know our focus and our directrix, we can figure these things out really quickly by finding the vertex, using kind of going in between those two, and then just knowing whether it opens up or down. The focus is always inside of the parabola, if that isn't something that you've made a connection with yet. So we have now identified our vertex. Right, it's at the point -6, -6, +2. Now that's not what I wanted. It wants us to find the equation. So because this is opening up and down, this is a vertical axis graph, we know our general form of this equation is x minus h squared equals 4py minus k. So what we just do is we just plug in our values of h, k, and p that we found, and then simplify if we need to. And so we get x minus h is -6 squared, and then our p value is 1, and our k value is 2. So I can simplify this left-hand side. X minus -6 is just x plus 6, and 4 times 1 is just 4. And there you have it. There is our lovely graph. There's our lovely equation. Now, if you wanted to do something to type this into your calculator, we just need to solve for y. So divide by 4, add 2, and you get an equation of y equals. You punch that into your calculator. So that's pretty nice. It's pretty easy, right? So let's move on. Okay. Now, I'm given this equation, -2x equals y squared plus 4x plus 8. I want to write this into this format that we've been dealing with, this y minus x squared equals 4p times x minus h. So there's a few things we need to do, okay? First of all, notice that I have x's on both sides and I have a y squared. And so what I want to do is I want to get all of my x's onto one side, okay? And then I want to isolate my y, because notice over here I just have this y squared piece. So to isolate my y squared, which is what I'm doing ultimately, I'm going to subtract 4x, and I want to subtract 8 from both sides. Okay, those cancel. And what I'm left with, -2x minus 4x is -6x minus 8 equals y squared. Now, I'm kind of getting there, and I'm going to rewrite this so that it's kind of the y squared on the left, just to make our lives nice. Y squared equals -6x minus 8. Now notice what this is going to transform into on this right-hand side is it's going to be 4p, so it's going to be a number, right? Because p is a fixed value, times x minus a number, or x plus a number. So what I want to simply do is I want to factor out whatever is in front of our x, in this case, -6. So we end up with y squared equals -6 times x. Now if I factor out -6, this -8 will become plus 8/6. Okay. 8/6 very simply is going to transform to 4/3. Now we're almost done. Okay. Because it says to give it in this form, I'm going to be very exact in that. And so I'm going to take y squared. I'm going to rewrite that as y minus 0 squared. Now, I have 4p in front, but I only have negative 6. So what I'm going to do is I'm going to write this as 4 times. Now, negative 6 divided by 4 gives me negative 3 halves. So negative 3 halves. So what I just did there is I just took 4p equals negative 6, right? And I just figured out what p needs to be. P has to be negative 3 halves. And so then I wrote it as 4p instead of negative 6. Okay. And then again, to be like super exact with this, I'm going to write it as x minus. And since it was x plus 8/6, it's actually going to be x minus negative. And 8/6 simplifies to be 4/3. And there we have it. So there's a whole lot going on here that is kind of unnecessary in a way. I mean, any of these are good points to be able to deal with a function and stuff like that. But by getting it worked down into this final form, just by simply looking at this, I know AHK and I know P, so I know my focus, I know my vertex, I know my directrix. I can just quickly graph this entire thing and be done with it. Okay. Now, let's graph this in a window, negative 10 to 2 by negative 10 to 10. So I am going to leave this mostly for you. We're going to get to the point where we can punch it into our calculator. But then I'm going to leave it to you and actually punch in your calculator because this is really a simple problem to do. Right? We already kind of did this up a couple examples ago. What we need to do here is we need to solve this for y. And so to do that, the first thing I'm going to do is divide by negative 5 on both sides. And so I get quantity y plus 2 squared equals x plus 4 negative 5. We just square root both sides. Y plus 2 plus or minus the square root of x plus 4 over negative 5. Subtract 2. Y equals negative 2 plus or minus square root of x plus 4 over negative 5. And then this is just going to be two equations, right? Kind of our y1 would be negative 2 plus the square root. And our second equation would be negative 2 minus the square root. And so you just plug those in. And so to change your window, again, this is 83 or 84 specific examples instructions. Right next to the y equals button is a button that just says window. And when you press that, it is going to give you a screen that says x min, x max, x SCL. So x min, x max, x SCL. And then, so for x minimum, you're going to want to have negative 10. For x max, you're going to put 2. And x SCL is asking the scale. So what this is asking is how far apart do you want these tick marks to be? And since this is pretty small from negative 10 to 2, we just do 1. If you were like doing like say 100 to, or like negative 100 to 100, you'd want to do the scale according to that, right? So maybe tens or something like that. Because if you leave it at 1, what it's trying to do is on your little calculator screen, it's trying to put 200 tick marks from left to right. And there's just not enough detail definition in your calculator. And so it just looks like a really thick x-axis. And so what you want to do is change that scale to kind of reflect that. Below that, you'll see y min, y max. Y min, we're going to do negative 10. Y max is 10. And again, y SCL, the scale, we'll leave it as 1. And then just hit graph from there. And so this idea of adjusting the window is kind of a really nice thing to be able to do to understand how to deal with that. It helps you to be able to solve some problems nice and easy. You know what? I don't want to. Let's do this. So let's skip this last problem because quite frankly, it's boring, tedious, and you would never do this any other way than graph these two functions and use the intersect feature on your calculator. Same thing if it opened left and right, you would just graph the kind of two functions as we did in example 6. So you have a graph of this horizontally opening parabola, and then use the intersect feature there as well. So that's it for this lesson, you guys. Have a great day. I will see you guys for lesson 10.2.